Good morning, geometry. Today we're going to move into squares and rhombi. Rhombi is the plural term for rhombus. We've talked about quadrilaterals, and we've talked about parallelograms, and we also talked about rectangles. Today we're going to talk about rhombi and squares. So if you can see, I'm putting them in a specific order, and we'll talk about that order in a little bit. But let's talk about the properties of a rhombus first. So here's our rhombus. Now notice the rhombus comes under the parallelogram and under the quadrilateral. I'm trying to organize my stuff here. And it's kind of over here like this. So what I know is that it has all the qualities of a quadrilateral, meaning it's four-sided, and it has all the qualities of a parallelogram. So I'm going to mark those on my rhombus here. So all my sides, my opposite sides are parallel, right? Opposite sides are congruent. And in a rhombus, all four sides are congruent to each other. So all the way around, they're all congruent. Diagonals still bisect each other. And new thing here is that diagonals bisect opposite angles. So the opposite angles are congruent, and they also bisect each other. And then the next new thing is that their diagonals form a perpendicular angle when they intersect. So let's write those things down. I'm going to move this down so you can see our picture here. So all of the things of a parallelogram, all the five qualities of a parallelogram. And then I'm going to say diagonals bisect, remember cut in half, two equal parts, bisect opposite angles, all sides are congruent. That means they are equal in measure. And then that last one is that my diagonals intersect to form 90-degree angles. So diagonals are perpendicular. So that means they form a 90-degree angle in the middle, 90 degrees, right? Let's look at some of these qualities here. So all of these are qualities of a parallelogram. I'm not going to write them down because I know that you already know them, and I'll write them down in the filled out notes. But I want to add these here, diagonals bisect opposite angles. So let's look at some of the examples here. Here's example 1. Write this down with me in your math journal. Example 1, we have a rhombus here, S, T, V, R, and my diagonals intersect to form W. If the measure of angle RST is 67, find the measure of angle RSW. So let's see, RST, that's this whole angle here, is 67. What's the measure of RSW? That's this angle here. So what do we know from our rhombus up here and our qualities here? Diagonals bisect opposite angles. So what does that mean here? It means that this diagonal, SV, cuts this whole angle in half. So if this is 67, if the whole angle is 67, then RSW is half of 67, right? Or 67 divided by 2. So the measure of angle RSW is 33.5. Not too bad there. All right, so let's look at example number 2. Here's example number 2. And then we'll move into squares. Here we have rhombus, R, same thing, R, S, T, V, and W's in the middle. Find the measure of S, VT, if the measure of STV is 135. So let's figure out what STV is. STV, that's this whole angle here. So we always look at that middle letter that tells us what the vertex is. STV is 135, and I want to find SVT. Oh, that one's tricky right here. I want to find this one. So what do we know? Well, we know from parallelograms that our consecutive angles, this one and this one, are going to be supplementary, meaning they add up to equal 180. So 135 plus this whole angle is 180. So that angle there, that whole angle, this whole angle here, is 180 minus 135. So that's what, 45 degrees, right? So if this is 45 degrees, I want to find half of that. So I'm going to do 45 divided by 2. That gets us 22.5. So measure of angle SVT is 22.5. Awesome. All right, let's move on to squares. So squares are at the bottom of our quadrilateral family tree, and I want to show you kind of what our quadrilateral family tree is. So we have a quadrilateral, and then we talked about our parallelograms, right? And those 5 properties. And then we talked about rectangles, and we just talked about rhombi. Squares are very special in that they have all of the qualities of a quadrilateral. They have all of the qualities of a parallelogram. They have all the qualities of a rectangle and a rhombus. So the only additional quality, I'm going to put my title up here, squares. They have all of these qualities. Plus, they have an additional quality of all of the sides being the same. So they don't have any additional qualities. They have all of these qualities put together. So all these qualities of a parallelogram, of a rectangle, of a rhombi make a square. So that means opposite sides are parallel, right? All the sides are congruent. All the angles are 90 degrees. The diagonals not only bisect each other, but they're congruent. The diagonals form 90 degrees in the middle here, and they also bisect the angles. So all of the qualities of a parallelogram, as far as being parallel and congruent opposite sides, all of the qualities of a rectangle, meaning those 4 angles are right angles and the diagonals are congruent, all the qualities of a rhombus that we just talked about, meaning perpendicular diagonals, and they bisect opposite angles, and all the sides are congruent. So all of those things make a square. All right, so let's look at some examples about squares. All right, let's look at this square named math. Here's our example 1. If math is a square, wouldn't that be funny? Math is a square, and S is in the middle. If MA is 8, then HT equals what? MA equals 8. HT equals what? So let's think about this. If MA here is 8, then HT, all of the sides are congruent, so I know that HT is also going to equal 8, right? if the measure of angle HST, we're finding the measure of angle HST. And let's see, the measure of angle HST. HST here is this middle angle. What do we know about our diagonals? They intersect to form a 90-degree angle. They're perpendicular, so I know it's 90. Even though they didn't tell us any information, I know that because it told me it was a square, so right? So I know that all those properties are true. Let's look at another one. If HS equals 2, then HA equals what? And MT equals what? Well, let's figure this out. If HS is 2, so HS is here, right? That's 2. What is HA? That means all the way across. Well, if this is 2, and I know that the diagonals bisect each other, that's also 2. So HA all the way across. If you said 4, then you are absolutely correct. And MT, what do we know about MT? Well, if I know that like a rectangle, the diagonals are congruent, then MT is also 4, okay? Let's look at another example, one that has to do with angles. So this is our second example. This is our last example about squares. So here is our square. It is ABCD. So created their names here. ABCD, and the intersection point for the diagonals is E. If AED is 5x plus 5, find x. I want to know what x equals. So let's see, AED is this angle here. And I know that those angles from my diagonals form a 90-degree angle. So what do I know about AED? I know that it equals 90 degrees. So I'm going to say 5x plus 5 equals 90 degrees. And then I'm just going to go about solving, right? Subtract your 5. So 5x equals 85. Divide by 5 here. Then x equals 8 divided by 5 is 1. That's 35, 7. So x is 17. So about a square, it's kind of interesting because the diagonals intersect to make a 90-degree angle. When you cut these in half, we've seen these before, it's 45. And we're talking about our 45-degree angles. So you may see that in the future. Really quickly, I want to put all of our note cards together in our quadrilateral family tree. So here's our quadrilateral. It's like grandfather, right? Here's our parallelogram, direct descendant of our quadrilateral. I need more space than a direct descendant of our quadrilateral. And then we have our rhombus and rectangle. So notice that our rhombus and our rectangle, they don't have anything in common, right? But they have this square. So there we go. There's our quadrilateral family tree. Notice that our rhombus and rectangle are like brother and sister. They don't have anything in common, but the square has what both the rhombus and the rectangle have, okay? That's where the family tree gets a little bit iffy. But we'll talk a little bit more about this, and especially looking at Venn diagrams.